All right, so now we are going to make a solution. All right. And again, I am Miss Stilton, and this is
Miss Porter.
All right, so first thing we're going to do is we're going to weigh 50 mLs of water and record its mass. So would you like to explain a little bit about?
Well, in 6th grade, we talk about mass being kind of like weight. If you talk to a physicist or a high school teacher, they're going to tell you that mass is different than just weight. But for us in 6th grade, we're going to say mass is weight.
Right.
We're using this balance here. In my class, we call this the El Cheapo balance because it's not incredibly precise. Our purpose for using this is to compare the weight of something on one side to the other side. And we pay attention to this white, I call it a tooth, on the balance, and when it lines up with the blue tooth on the balance, then we say that the two sides are equal. And then we can look at what is on each side and make some decisions about mass. And before we start making the solution,
Yes.
I just wanted to remind people what a solution is.
Yes.
It is 2 or more materials stirred together, which sounds an awful lot like a mixture, Miss Stilton.
Yes, it does.
But there's something special about a solution. A solution must have one part dissolve into another.
Exactly.
So the difference between this and other kinds of mixtures, because a solution is a mixture, the difference is that something must dissolve. If it doesn't dissolve, if it doesn't leave the solution clear, it can't be a solution.
And one of my favorite quotes that I think you taught me a couple of years ago is a solution is always a mixture, but a mixture is not always a solution.
Right. If I stir together a wonderful vegetable soup, it's not a solution because my corn and my peas do not dissolve in the liquid. It's a mixture, but it's not a solution.
A tasty mixture.
Tasty mixture, you're right. So what do we need to do first?
So first we're going to figure out the weight of 50 mLs of water. And it looks like my lovely assistant, Miss Porter, has already drawn up the water again.
Okay. Can I point something out?
Yes, please.
I want you to notice that there is no air bubble in this.
Very important.
I have only measured water. If you do not put the tip of the syringe deep enough into your water and pull up the plunger, you're going to get air, and then you won't have 50 mLs of water. You'll have 50 mLs of water and air.
All right. So we'll add the water to 1 cup.
And while you're doing that, I'm going to make a sticky note
I think that's a fantastic idea.
with W for water.
All right.
So we know that this is just
Plain
water. Is this a solution?
Well, no.
Why not, Miss Stilton?
Because it's just water, nothing else is added to it.
It's just one thing.
Just
we
one
haven't
thing.
stirred 2 things together.
No.
Okay.
All right.
So now we need to record its mass.
Yes. So what we're going to do is, well, because there's a hole on this side of the balance, we're going to use an empty cup.
Now,
Okay.
we're assuming the weight of this cup and the weight of that cup are the same.
Yes.
So when we start adding gram pieces, what we're really weighing is what's inside the cup and how
Exactly.
much it weighs. We're trying to find out its mass.
Exactly. All right.
So I'm going to give you 10 gram pieces.
All right.
And do you think 10 gram pieces will be enough?
It's awful light. I'm going to say no. Maybe at least twice that.
All right. Well, why don't you put in 10?
All right. Okay. Didn't even move.
Wow. Here's 2,
All right.
4, 6, 8, 10 more. So we now have
Right.
20 grams.
All right, 20 grams. What do you think?
Still didn't
Still
move.
didn't move.
Okay. Here's
All right.
2, 4, 6, 8, 10, 30 grams.
All right, here we go, another 10.
Still not moving.
Oh my gosh.
So the mass of this water is more than 30 grams. You
Okay.
know that.
All right,
Here's 10 more. 2, 4, 6, 8, 10.
All
So
right.
this is now
here
40.
we go, adding 10 more to 30.
Oh, I saw a little bit of a bob.
Oh, it moved a little bit.
Do you think at this point we should add them one by one?
I think that's a good
Okay.
idea, now that we got some
All right.
movement there. All
Okay.
right, here we go.
41. It's moving. 42, 43, 44, 45, still not equal. 46, 47, 48. Whoa! I'd add one more and let's see where we are. 49. I think one more.
One more.
Okay. So I'm waiting. This is the hardest part
Yes.
about using these El Cheapo scales. They teeter-totter a lot, and you want to put your hand on them to stop them, but
Yeah.
you can't. So at this point, I notice that this movement in the middle is much less, and it's looking like it's lined up. I know it hasn't stopped, but I'm going to make a judgment call there.
I think that's a good idea.
So 50 mLs of water is equal to 50 grams. I want to point one thing out. This is a liquid. We always measure our liquids in milliliters
Yes.
or liters. These gram pieces are solid. Solid measures are grams. So we measure solid things in grams, liquid things in milliliters.
Yes.
So we would be writing down here, the mass of 50 mLs of water is 50 grams.
Yep.
All right, number one's done, check.
Step one. All right. Now we need to make a solution with 1 level spoon of salt and 50 mLs of water.
So I'm going to change the label on this.
Good idea.
This is no longer water.
All right.
It's going to be a salt solution.
Exactly.
When Miss Stilfen adds the second part.
So we have our scoop of salt.
So a solid is being added to a liquid. We're going to stir, and if it does that special thing called dissolving, where the salt is going to break down into much smaller pieces, and it's going to actually fit between the small spaces in water.
Yes. Which is amazing to me. Water has space.
I know, you can't see it when you're looking
Can't
at
see
it.
But
It's on a very small level. So it's going to fit, break into small pieces,
Yes.
and fit evenly throughout there, no matter where we look. If we had zoom lenses and we could see the salt in the water, we'd notice that it spread out evenly throughout the entire mixture.
Exactly. And
I-
it's doing that special thing that it does, because
It's
I'm
clear
not
now.
seeing the crystals anymore.
I can see the stir as you
Yeah.
stir.
There's no more crystal pieces in the bottom anywhere.
So we have a solution. Hooray!
The magic of solutions.
Now, what does the directions say? Carefully weigh the solution. I want to see what happens. We know we have 50
50.
grams over here.
Exactly.
You out in TV land, I want you to make a prediction before
Yes.
Miss Stilfen puts this down. What will happen to the balance when she puts this down? In other words, does the salt have weight, even though it's dissolved? And will that weight of the salt, if it is there, affect the balance? All right, let's find out.
All right.
Aha!
Hmm.
Just as we suspected.
It definitely moved.
Because this side of the balance goes down, it means that this side, whatever's in the cup, is heavier than whatever's in that cup.
Exactly.
So think now, where do we need to add the gram pieces in order to make this tooth come back to the center. Do we need to add it in the solution side or the gram piece side? What would you say, Ms. Stilton?
Well, I would definitely say we're gonna have to add it to the gram piece side.
Now, I'm going to make a prediction. I want to show
Yes,
1 gram piece up close.
they're pretty small.
A gram piece weighs about the same as 7 small paper clips. That's what someone told me once.
Yeah.
It's not that big and not that heavy. I'm going to predict that it will take at least 4 of these
4 of them?
to equal out, at least, could be more.
Okay.
4 gram pieces to equal out the El Cheapo scales again. What do you think?
I'm gonna say, I'm gonna go a little less. I'm gonna go 3.
3.
3.
Okay. Well, here, let's take turns. So
All
we
right.
know we have 50.
50 in there.
So now we have 51,
52.
53. I still, from appearances,
It
would
looks
say
like
this
this
looks
side.
like it's a little heavier.
Yeah. Well, there goes my guess.
It's all right. Predictions are based on knowledge, but they don't have to be right.
And 54 now.
This is tough.
Again, it's that you really want to stop, but
I
you
know,
can't.
it's
You have to
frustrating.
be patient. All right, so we have 54 grams so far on that side.
So what that means is there are at least 4 grams of dissolved salt.
Yes.
And if I'm trying to figure out the weight of something that has dissolved, I can weigh it even if I can't see it.
You got it.
All right.
I don't know, what do you think?
You know, I would say let's add 1 more and see
What happens?
what happens.
All right, so this is going to be 55.
And again, we're waiting. And I'm also looking just to see if it looks level. I almost think that this side
Yeah.
looks like it's dipping down a little further.
Yep, that's what I was going to say.
So I wonder what would happen if we remove one of those.
Right?
And of course, when we remove it, we have to be careful not to jostle too much. Nicely done, Miss Stilton. Okay. To me, that looks more even.
Yeah, I agree.
So our result is that water on its own weighs about 50 grams. If we have
Yes.
50 mLs of water, it's 50 grams.
Yep.
We added 1 blue scoop of salt,
And we stirred it.
and we stirred it, and the salt dissolved,
Yes.
which made this a solution,
Exactly.
and it changed the weight because we
Obvious.
added salt, and salt has weight. And the weight of salt and water combined, 50 mLs of water, 1 blue scoop of salt, is 54
Yes.
grams. All right, that's a result worth writing down, boys
Yes,
and girls.
please do.
And is there a question at the
There-
bottom of the page?
There's actually a quick little math problem that they have to do to figure out the mass of the salt that is actually in that water. Because we know that the total of salt and water is 54 grams, that's what we got. And then that the mass of water is 50 grams. So now we just want to figure out the mass of the salt. So you're going to have to take your salt and water, 54 grams, and subtract 50 grams of water. And we got 4 grams of salt that we added to that water.
No, Ms. Stilfen, in my class, we wondered why we just didn't take a scoop of dry salt and weigh it. Maybe for extra credit, we
Sure.
could do that.
Ah, absolutely. That is a possibility. Let me get another scoop of salt out here.
So we have 2 cups that should weigh the same.
Right.
Should weigh the same. I like that one better.
Yeah, me too. Okay. All right,
So in science, if we can prove something in more than one way, that's a good thing.
absolutely. Okay, so 1 blue scoop of salt. Put it on the side.
And it definitely has weight when it's dry.
Yes, as you can see, it went down.
So now, I've added 3 grams. And we said it was 4 grams. I'm going to add the 4th one. And this is a time to talk about the fact that we're human beings in lab.
Mm-hmm.
Sometimes if we didn't pay attention to making sure we had a level scoop, like I have to admit, my scoop of salt might have been a little less level than yours, Ms. Stilfen. So our results can vary, and part of the reason we have many lab groups do this work is because with multiple trials, meaning more than one time of doing something, if we get the same result, we believe it more.
Exactly.
Are you, oh, that's
I was
a
just-
not level
That is
one.
not a level scoop of salt, and I have seen many groups do this. So there's an unlevel scoop there.
And so in this case, a blue scoop of salt weighs more than 4 grams
4
because we
grams.
weren't accurate and precise in our measurement.
Exactly.
So if your results vary, it's a good idea to ask your lab group, why are their results different than ours?
Yes.
Let's find out if they did anything differently.
Exactly. Human error. Have to account for human error. All right. So our question,
Okay.
now that we've decided that yes, it was about 4 grams of salt in there, measured it dry as well as in the solution. Your question now is, how could you separate the salt from the water in the solution? So there it is.
So we have a saltwater solution. Your last investigation asked you to separate some different mixtures. And we found out that some tools work for some materials. So think about, how are we going to get the salt back out of this so that we have only salt?